All right, good morning. So, pre-calculus. So today we are going to be talking about rational functions. And I'm going to go out on a limb and say I will bet that your coverage of this stuff in college algebra was maybe not as complete as I would have hoped for, but I have nobody to blame. When I teach college algebra, I typically move this around so that this is the last thing, because quite honestly, it's not the easiest of topics. Okay, there's a lot to remember. It's not that it's really hard, but there's a lot to remember and a lot to keep track of. Okay, so the things that we have to worry about here, right? We have a rational function, and it's usually some kind of a p of x divided by a q of x. P of x and q of x are both polynomials. Okay, there's other rational functions, right? You can have a square root in here, but those are usually more difficult, and we're not really going to talk about those for this section. It's just going to be, these are both polynomials, okay? And q of x is not going to be a constant, because if I just give you, like, x squared over 2, that's really not the same thing as like an x squared over a 2x plus 1, okay? So we're not going to worry about these too much, because it's just, we could rewrite this thing as 1/2 x squared, and now it's back to being a polynomial again. Okay, so not rational, rational. Okay. Okay, so those are our pieces. All right. So there's a couple of things that we got to worry about. Okay, and the first thing we usually have to worry about is asymptotes. Okay, it's a very bizarre word to spell, but that's our first kind of a thing that we have to deal with. There's two kinds. Okay, there's vertical asymptotes, and that is where q of x is equal to 0. So if you have some kind of polynomial down at the bottom, 2x plus 1, for example, the asymptote is going to be where it's equal to 0. But remember I said there's a lot to keep track of? See, already I've jumped the gun and didn't do anything. So the first thing, step 0, okay, step 0 is we have to check for common factors. Okay, and that means something like, what if we had like an x squared minus 9 divided by an x plus 3? Well, you're looking at this like, well, isn't it just x minus 3, x plus 3 divided by x plus 3? Yes, that's exactly the step I want you to make. And then you're going to look at this and you're going to say, hey, wait a minute, I see something that cancels. So why isn't this just the same thing as the graph of y equals x plus 3? And I said, do not forget the first section that you did in this book, which was 1.8, where they had all of those weird, p of x and q of x, and they asked you to do all of that stuff, and you had to track the domain forever and ever and ever. Well, those rules didn't change. You still have to keep track of the fact that x cannot be -3. Okay, so really, you're right. You are going to treat the function like this, except in one place. Okay, so when I go ahead to graph y equals x plus 3, right, we're going to have something like this. We're going to have, right, when x is 0, y is 3. When y is 0, then x is -3. Okay, but x can't be -3, can it? So what we have here is we have a hole that goes through here. Okay, and we get holes when we factor. When we cancel a common factor, we are left with that hole. Okay, and that is a way different kind of a function. This feels a lot different, right, from a rational function as it is just a linear function with an exception. All right, so it's actually technically a piecewise function, right? We don't have a value for this. But that's the first thing you want to do, is you want to check for this common factor because the treatment of this point x minus 3 is not an asymptote. It's a hole. Okay, so it's something to remember, like, hey, wait a minute, double check that first, okay, and then we're going to go forward. Okay, and I know that the college algebra class has changed, so we don't really deal with this very much. So you'll see a few in this section, okay, but that's, just to make sure that we're checking that. Okay, so the step 0 is check for common factors. Okay, is anything cancel? If it does, well, then you have a hole, not an asymptote. Okay, so there's a joke there, I think, but there we go. All right. So the first thing we're going to do, once we've checked for common factors, I guess the second thing we're going to do is we're going to check for vertical asymptotes. And you may or may not have one. Do you always have a vertical asymptote? Oh Lord, my handwriting is the worst. Like, no, not always. Right? What if you ended up with something like an x over x squared plus 1? I mean, you can't solve this for 0. I mean, not in the real plane, right? Not with real numbers. So, when we graph it on our xy plane, this thing does not have a solution. So this would not have a vertical asymptote. Okay, so they don't always have a vertical asymptote, and that's okay, but they often do. So that works too. Okay, but if you don't find one because it's like, well, it doesn't equal to 0, that happens. That's fine. So that's the first thing. Well, I keep saying first, like, we've checked for common factors. Okay, so assume we've checked for common factors. Once we've done that, we're going to sketch in our vertical asymptotes, if there are any. All right. And that's a very common question to ask first. Identify all the vertical asymptotes. Okay. And you cannot ever cross a vertical asymptote, because if your graph crosses that vertical asymptote, well, that means there's a place where you've divided by 0. You really want to avoid that if you can be helped. Great. What about horizontal asymptotes? Okay, so this is where rational functions get to be very difficult, because there's a couple of different cases that we have got to go through and start figuring out. Okay, first off, you can cross a horizontal asymptote. Okay, so you can cross that horizontal asymptote. So vertical asymptotes, those are strict rules. Horizontal asymptotes are guidelines. Okay, because if you have a function that looks something like this, if you're going to go into electrical engineering, you're going to see stuff like this all the time. We have, right, a function that kind of meanders through this axis. Okay, and we'd like this, we call these asymptotes. Okay, we still consider this to be an asymptote, even though your function may only cross it an infinite number of times. Okay, so this is, we want to still use the word asymptote here, and we do, and we treat it like an asymptote. But as long as your function only crosses it an infinite number of times, then we'll be okay. Okay, so we can cross, and there's no rule on how many times it can cross. It can cross once, twice, or a lot. All right. So horizontal asymptotes these are guidelines. These are not rules, but they do have properties that we'd like to expand to things like this. Okay. And there's a number of different conditions that we have to check for horizontal asymptotes. Okay. So for our rational functions, right, we have a p of x and a q of x, right? So we have our rational functions in this form. This is not the form we have for rational functions right now, but we have to look at the degree of p of x and the degree of q of x. Okay, I just want to give you a heads up as to where this is going, and we'll try to get to a couple of homework problems today, but I think I left this homework open for like an extra week because quite honestly, this is a long section because there's a lot of stuff to consider and a lot of stuff to cover with it. So understand that this one is not due at the end of the week, it's due at the end of next week, simply because we ain't gonna get through it this week. Okay, we got Wednesday, and then we'll probably finish this thing up on Monday, maybe Tuesday. All right, depending on how many examples we do. So just to kind of give you a heads up, like you're not looking at this and saying, I have to memorize all of this tonight. No, that's a lot. Okay, so we have 4 conditions. 1, what if the degree of p of x is less than, I'm going to go ahead and use that, okay, is less than the degree of q of x. Okay, so what that means is you have a smaller polynomial on the top than you do on the bottom, something like x squared over x cubed plus 1. All right, so like 2x minus 1 over x squared minus 1. Okay, the degree of the top is 2, the degree of the bottom is 3. Actually, I have a colleague that gets mad at me when I say that. The degree of the numerator is 2, the degree of the denominator is 3. Okay. The degree of the numerator is 1, the degree of the denominator is 2. Okay, like, we taught them these words, you should use them. You're right, we should. So 1 over x, right? The degree of the numerator is 0, the degree of the denominator is 1. So anytime the degree of the numerator is smaller than the degree of the denominator, then we have a horizontal asymptote. At y is equal to 0. Okay, it's just the x-axis, or it's just the y-axis, right? No, it's the x-axis, sorry. It's just the x-axis. So if we're going to go ahead and graph this, right, for all of these, this way. I never like doing this on the whiteboard because the inks run together and then you've got a dirty marker to deal with. Okay, so we have the line y equals 0, right, as our asymptote. Okay, that one doesn't seem so bad, and it's not. When you get one of those, catch yourself lucky because it's a pretty easy one to deal with. So, what if the degree of p of x equals the degree of q of x? Quite frankly, this is one of my more favorite examples to give you guys on quizzes or on a test because these are fairly straightforward. These can be very straightforward problems, and they ask everything that you would ever want to know. So examples of that, right, would be something like 3 minus x over 4x plus 1. Okay, the degree of the top is 1, the degree of the bottom is 1. They're the same. X squared minus 1, x squared minus 5x plus 6. All right. Again, no common factors. We have to check in these cases, but the degree of the numerator and denominator are the same. Okay. We could do a cubic, right? We could do an x cubed minus 1 over x cubed. The degree is the same. Okay. So here we are for all of this. All right. Now, what do? We have a horizontal asymptote. Okay. Along the ratio, right, of like whatever the leading coefficient. This is the leading coefficient of P divided by leading coefficient of Q. Okay, so it's just the leading coefficients of the two of these. All right, I think the first one is the only one I actually have that's even remotely interesting here. So we have y is equal to leading coefficient here, -1. Leading coefficient on the bottom, 4. Okay, so the line y equals -1/4, that's the horizontal asymptote here. For the other two, leading coefficient is 1/1, leading coefficient is 1/1. So in both of these cases, the line y equals 1 is the horizontal asymptote for both of these. Okay? All right. So be careful with this because this kind of problem is one of my favorite tricks to do. I try to fool you to think about what leading coefficients are. So be real careful when you're looking at these because, you know, they can always do that. How did I get -1/4? Thank you. So what we're looking at here is the leading coefficient of the top. 3 minus x, the leading coefficient, right? This is really 3 plus -1x. And since x to the 1 is the highest, right? That's how we got the degree. The number in front of it is the an. Okay. On the bottom, the leading coefficient is just 4. I think that was a lot easier to see. Okay. So that's how we got the -1/4 was because we took the leading coefficients. Okay. So again, be real careful because that's like my favorite trick to do to you guys is to do something like, you know, 4 minus 3x over 5x plus 1. And then have you guys come up and tell me that the horizontal asymptote, right, is the line -3, because that's the number before the x, divided by 5. Okay, so just be real careful that you're actually getting leading coefficients, and don't let me trick you like that. Okay, it's a very easy thing to avoid, but because there's already so much to remember, it can be difficult. Okay, so next, all right, we're going to have that. So next we're going to have 3. This is the fun one, by the way. What if the degree of p of x plus 1 is equal to the degree of q of x? Okay, and what we mean here is the degree of p of x is 1 larger than q of x. Okay, so you're looking at something like x squared minus 1 over x. It's a little bit bigger. Okay, I'm going to have to do one of these, so this one is a good one to do. You know, we have something like you know, x squared plus 3x plus 4 over, say, oof, yeah, we could. I would not want to do this one like that. All right. The degree of x here is 2. The degree of the polynomial is 2 over 1. Okay. Now, in elementary school, we had things like improper fractions, right? We had like something like 4/3. And they made you do this, right? They said, oh, this is 1 1/3, right? That's how we did that. One way to do this is to just kind of realize, like, do addition. But we can't do that. So when we get this case, we have what's called an oblique asymptote. Okay, or a slanted asymptote. Now, this still counts as a horizontal asymptote. Okay. As a matter of fact, you could say a horizontal asymptote is actually a special condition of oblique where it's flat and not slanted. But they still count like in the same category of what we deal with them, or how we deal with them. So that's just what we're going to go with. All right. How do you get the oblique asymptote? Well, in college algebra, maybe, and definitely in intermediate algebra, we taught you something called polynomial division. And what we have to do right, is do polynomial division. So we have to go through and actually do all of this. Okay, do you remember doing this and how much fun it was? So we're going to say x goes into x squared, x times. Okay, so x times x is just going to be x squared. And then we subtract, right? That's how that works. 0, 0. And then this just didn't go in, right? X goes into 0 x's 0 times. Great. And then we have a -1, and x does not go into -1, so this is our remainder. So we could say, we could rewrite this, right? We could rewrite this, and that is equal to x minus 1 over x. Okay, and you can think of the formula. You can actually think of this, right? This function like this instead, and that'll be just fine. Okay. As a matter of fact, when I took trig, we spent it's a different class than when I took it in the 80s, the 1980s, just to put that century on there for you. It was a much different class because mine was, my trig class was more geared to electronics majors who had to read oscilloscopes. So we spent a lot of time like adding and subtracting functions graphically. So this would have been something that we would have done back in the day. We treat it a little bit differently now. Okay, but our horizontal or oblique asymptote rather is this guy right here. Whatever's up here, that's our oblique asymptote. Okay, whatever is up here actually, the whole thing. So our oblique asymptote, in this case, y equals x. That's our oblique asymptote. All right, and then we can go ahead and graph the rest of this thing. All right, I guess I could do this one. This is going to be delightful. All right, this is going to be too much fun. So just to give you an idea of like maybe we finish this one, maybe not, but to do something like this, right? We have to do 3x minus 1 goes into, okay, x squared plus 3x plus 4. All right, so how many times does 3x go into x squared? They have to match. Remember, they have to match. So this is going to be 1/3 x times. Okay, you see how much fun this is going to get? So when I multiply, right, 3x times 1/3 x, we're just going to be left with x squared. That's this thing, right? Minus 1/3 x's, all right? Minus 1/3 x, because it's -1 times this thing. We put that down here, all right? I just came up with this problem off the top of my head, so it's going to be really, really nasty. Most of the ones they have in the book, if they have any like this, or quite frankly, the ones, you know, if I do read another book to go get this, to get a problem like this, they're usually done out a little bit better, so they're not quite as awful. Okay. By the way, if you're looking for an additional source of problems, there's an online pre-calculus book called Stitz and Ziegler. Okay, he does college algebra, trigonometry, and then they combine the two of them and call it pre-calc. We don't use this book so much. It's online and it's free, but first off, it's a PDF, and a lot of it's a black and white. There's no color. There's no nice diagrams. A lot of students get upset with that format, and these are written by guys that are, I assume they're guys, mostly because of the sense of humor. Okay, they write with a sense of humor that's a little bit more crass than a professional book like the one you have. But if you can tolerate a little bit of humor with your math, this is a good source of problems, and sometimes provide a good alternative explanation for things. Okay, but I will warn you, they're not well. It's a good book, but there's some humor to it, and it's not nice. They don't tell terrible jokes though. They're just a little bit like, if you don't know what gallows humor is, they're kind of like that. Subtract. Okay, so here we have, right, this is a positive. So we have x minus x squared minus x squared. cancels. That's great. That's what we want. If this first term does not cancel, you've done something horribly wrong. Fix it. This one, we've got, let's do a middle minute problem here. We've got 3x minus, right, a 1/3 x. How do we do that, right? So this is 9/3 x. That's a fancy way to write 3 plus 1/3. So we end up with 10/3 x here. So we have 10/3 x here plus 4. Okay. Now, 3 times what equals 10/3, right? 3 times what is equal to 10/3. All right. So wouldn't that be something like, right? That would be u is equal to 10/9. Dang it. 10/9. Okay. So this would be plus 10/9. And when I multiply this, right, they're going to match, right? That's that we just did it that way, specifically for that. Okay, I'm just going to let you know, I'm never giving you a problem that's this hard, okay? This is not happening. But you never know, right? You never know where your travels will take you. And if this ever ends up happening to you, like, oh, we just divide, we'll just do this, and you'll be all set. And people will look at you like, how did you know that? You're like, yeah, I'm just that smart. I'm that good. Okay, so these are going to cancel. By the way, if you ever go to UNM, you're like, wow, how'd you do that? Just let them know you're really that brilliant. Okay. So this is 4 is a fancy way to write 36/9, right? Or if you go off to TAC, I'm not brilliant because I went to CNM. Thank you very much. Okay. Or how are you not that brilliant? Okay, that's the remainder. I shouldn't put plus there, it's the remainder. Okay, so our oblique asymptote here, this is a really long and terrible problem, but our oblique asymptote is y equals the line, right? 1/3 x plus 10/9. Okay, that would be a problem by itself. I would not, it would be nothing else. If I gave you one like this, we'd be done. We'd say, what's the oblique asymptote for this function? And that would be your answer. You're done. I would not ask you anything more after this, because this has already been terribly long. Okay, there are already too many places to mess up for putting a fraction in. It's just, this gets to be nuts. Okay, this top one, not so bad. I wouldn't feel bad about making you do more. We're actually even giving you this problem. Okay, I would sleep well at night if I gave you this problem. This one, I probably wouldn't sleep well because I would think I was probably too hard on them. Okay, this is too much. Especially if I asked a follow-up question, right? That would really be bad. But that's how you do that, okay? That's how you go through and do it. And they're horrible. Okay, they are just absolutely horrible. But that's what you do when the degree, see, we're only in step 3, we've got one more. That's what you do when the degree of P of X is 1 larger than the degree of Q of X. Okay. So 4, last one, promise, okay, this is the last one. So what do you do when the degree of P of X is larger than the degree of Q of X by more than 1, okay? So here's the degree of P of X plus 1 is greater than Q of X. So what we're talking is like the degree of P of X is 2 more than the other one. Okay, so something like x cubed minus 1, say over x plus 2. Okay, degree of 3, degree of 1. This is more than 1 apart. Okay, 5 plus some stuff. Something like that. Okay, more than 2 apart. Okay, x to the 6 plus some stuff over x squared, right? More than 2 apart. Then we say there is no asymptote. Okay, there is no asymptote. For our book, And quite frankly, for every book that I've seen in the past 10, 15 years that are rated at this level, they all say there is no asymptote. Okay. What really happens, and this is a calculus term or calculus thing, is you still do this division. Don't do it for our class because you're not required to. Okay, we don't make you do this. But you would still do the division, and that function that you'd have up on top, you'd have a y equals f of x as, I'll put it in quotes, asymptote. It's not called an asymptote anymore. It's called a limiting function. Okay, it's called the limiting function. So the graph is going to the graph of the rational function is going to kind of hug this like it does an asymptote, but it might be a parabola, right? And it can still cross, okay? But the end behavior is going to look a lot like this asymptote, and it might do some other stuff in the middle. It might have a vertical asymptote somewhere, okay, and that's fine. So, you could get something that would look some, let me put my vertical asymptotes in, put those in green. So maybe it's got a vertical asymptote here, and you get this crazy looking function like something like this, because it can cross, it's fine. And you might get something like this. Okay, just as an example. But it would look a lot closer to this this parabola here, but in the middle it might do different stuff. But again, not something you ever have to worry about. Okay, even in the calc classes, we really don't go into this a lot. I think mostly because we have things like Desmos now. But that's that's what you do. Okay. So we've talked about where are the vertical asymptotes, if there is one. Okay, we've talked about having to check for common factors, and we've talked about what plethora of things you can do for horizontal asymptotes. And yeah, these are things you kind of have to remember. Okay, so when you're doing your exams, like this is not given to you. You just kind of have to know. I tend to not ask this one so much because there's not really a lot to do. I can, but the kind of way I would ask this would give you a problem that had parts like A, B, C, or D, and it would have different functions, and it would just be kind of like a multiple choice. Like this function does not have an asymptote. This function does have an asymptote. This function has a horizontal asymptote, but it's oblique. So I could go through these options kind of like a multiple choice test or a multiple choice question where you would just have to point out which one is which. Okay, that's the nature of the kind of question I would ask you to do. Okay, if I was going to ask you all of these things. My two favorites, this one, of course, right, where it's one bigger, and option two. Okay, so those are the ones I would definitely concentrate on, but that's where we go with that. So let's just have a look at some of the problems that they throw at us. Okay, and there's going to be a lot of examples in this section, so we will definitely review some of this next time, and we will definitely go through and deal with some things. Okay, so great, more notation, you'd think. All right, actually, you know what? Can we just go to reinforcing what we just did? No. This is a little better. Okay. So we pick our problems for exams based off of what we have for homework problems, and even in a face-to-face class, I don't just put this down and say graph, because there's a lot to keep track of and there's a lot to know. So even in a face-to-face class, I usually put these little pieces here. It's like, I'd like you to identify the x-intercepts. I'd like you to identify these things, okay? And actually walk you through this, because there's a lot of follow-up questions we could have with this, okay? We'll get to some of those next time, but there's a lot of There's a lot of questions that follow on to these four things. So it's not fair to a student to say, oh, in addition to all the asymptote rules, you got to remember how to do all of this too. No, it's too much. So let's just go through and deal with this. Okay, we have f of x equals, just hold, red is a stressful color, so let's move back to blue. Okay, we have 4x minus 3. We have x squared minus 25. Say, what is the x-intercept? Well, to figure out the x-intercepts, right, to figure out intercepts at all, we have to take turns, right? The different variables have different values. And if you are still in the spot where you were calling this y equals f of x equals this thing, or y equals this, that's fine, okay? The function notation is great, but I also understand it gets some acquaintance. You need some acquaintance here. So if you're looking at this to solve, it's fine. I was doing that for years to do that because it made more sense to me to plug in for things. Okay, so x-intercept is, that's when y is equal to 0, isn't it? So what we're going to do is we're going to say this is minus 4x over 3 divided by x squared minus 25 is equal to 0. Okay. So going back to your intermediate algebra days or your high school days, and I ask you, and I say, how the heck do you solve a rational equation? Well, the first thing you do is you turn it into something that isn't a rational equation. These are terrible. So we're going to multiply this by x squared minus 25. X squared minus 25. That's going to cancel this bottom. 4x minus 3 equals, oh, isn't that convenient? 0. And then we're just going to solve this. So negative 4x minus 3 equals 0. Negative 4x is equal to 3. And x is equal to 3 over negative 4. Now, is that the same as negative 3/4? Is that the same as negative 3/4 like this? Yeah, these are all the same. Write it however you'd like. I know I only have one of these because I only had one solution. Okay, so my x-intercept here is x is equal to negative 3/4. Y is equal to 0. Okay, so here's my x-intercept. Negative 3/4, 0. All right. Write the equations of the vertical asymptotes. Okay. So how did we find vertical asymptotes? We set the bottoms equal to 0, right? We set the denominator equal to 0. So to find a vertical asymptote, right, set x squared minus 25 equals 0. You could kind of tell by inspection there's no common factors here, right? I mean, this is x plus 5, x minus 5, and this doesn't look anything like it. So we're going to say that's what you write when you your teacher says show work. You're like, but it was obvious. You just say by inspection, right? No common factors. Right? You may get a teacher that tells you you can't do that, but most of they'll probably be they'll be pretty impressed by the whole by inspection business. Okay. So to solve this, right, that's x minus 5, x plus 5 equals 0. So by zero factor principle, this happens. So we get x equals 5 or x equals negative 5. Okay. On my part, if I ever give you problems we have to work out by hand, I really like to see you write down the zero factor principle step, because later on we're going to be dealing with things like, for now, if you skipped it, I would not have a question like, I wonder how they got these answers. No, I know how you got those answers. It's okay. I won't question you. I will give you credit for doing this. I would never like say you need to show this work. But later on, right, if you've taken trig, you're going to get trig stuff in here, and then you're going to have to solve it after that. Or if you remember college algebra and your teacher actually got to the end of the class and you guys did logarithms, You might have exponentials or logarithmic functions here. Okay, so just to give you a heads up, you think, why are you writing these? They're too easy. Like, they ain't always going to be easy. All right, so our vertical asymptote, right? The line x equals 5, the line x equals -5. Okay, I try to do it this way now because I did have a student that complained, and he was right. She was right. Absolutely, it's ambiguous just to write down x equals 5. You're like, is that a solution or is that a line or what are you doing? So I just started writing down the line because I think it makes it more clear. Okay, so equation x, oh, what happens if I have more than one? X equals 5. We're going to try it this way. X equals -5. Okay. This one I would actually like them to do it one at a time. So they don't. Okay, what are we working with here? Okay, what kind of an asymptote do we have? Okay, are we always going to factor the denominator for a vertical asymptote? If possible, yes. Yes, you are always going to factor that denominator for your vertical asymptote. Okay. Again, if possible. If the bottom was like, then you can't factor it, you're done. All right. So, yep, if it's not possible, there isn't a vertical asymptote. That's your answer, right? So you're not guaranteed to have one. And sometimes you're just not going to, and that's okay. All right. So the horizontal asymptote, what condition do we have, right? Let's go back and look at it. What's the degree of the top? What's the degree of the bottom? Okay, the degree of the top looks like we have a 1 here. They didn't try to hide it by writing it backwards. The degree of the bottom is 2. Oh, well, this one is smaller than that one, right? P of x is smaller than Q of x. So the condition we have is P of x is smaller than Q of x. Right? The degree of P of x is smaller than the degree of Q of x. And if I go back to my notes here and say, what the heck was going on here? Oh, the degree of P of x is smaller than the degree of Q of x. That meant we had a horizontal asymptote at y equals 0. Okay. And honestly, for the first couple of these, if you're looking this stuff up, that's exactly the process. Okay. Eventually, you'll be looking this up and you're like, I'm getting tired of turning back these pages. I should probably just remember a few of these. So this comes with time and it comes with practice. But there we go. And here's one thing. I mean, I do like your book. I think it's not a bad book at all. But this drives me nuts because horizontal asymptotes are slant. I don't even like slant. I like oblique. These are not. These really are the same. If you've got a horizontal asymptote, you do not have an oblique asymptote, and vice versa. If you have an oblique asymptote, you do not have a horizontal. Okay, that's for the problems they would throw at you at this book. It's okay. We could probably have some kind of a function that did this, right? Where we had maybe we had here's an asymptote that we had some kind of a function that did this. Like, that's possible, but here we're talking about a piecewise functions on top of a rational function with two different asymptotes going on. There's a lot, and they don't throw this kind of problem at you in any book. All right, this just isn't happening. Okay, it can happen, but we really have to go out of our way to make it happen. So you can't have a horizontal asymptote here and an oblique asymptote, but you're going to see this really squirrely function of, this piecewise function that's two rational pieces, and one of them is going to look terrible. Okay. If you've taken trigonometry, which it's not a prerequisite, and you get inverse tangent, that's the only function that you really have that you have two asymptotes. And it does happen, fairly common. That this is a very common function in calculus. But that's the only function that has like two different horizontal asymptotes that you ever have to worry about. So your book with this is also not a rational function. This is trigonometric. So in your book, the only one you ever have to worry about is it's either horizontal or it's oblique. They do not cross over. Okay. So you're not having to go through and do that. Okay. Oh, last one. What about y-intercepts? Okay. Now we already did the one where, right? We already set y equal to 0. Solve for x. Sorry about that. My heater. That was for the x-intercept. For the y-intercept, it's backwards. We're going to set x equal to 0. I'm using solve here in a very loose way. Solve for y. Okay. So all we're going to do is we're just going to set x equal to 0 here. Okay, let me go back and look at my function. Negative 4x minus 3. And this was what? X squared minus 25. So set x to be 0. We have 0 minus 3, 0 minus 25. Okay, then 3/25. Okay, so x is equal to 0, y is equal to 3/25. Okay. Now I'm going to hold my breath when I say check because there's a lot of information. See, I would have liked them to have said check your answer on each one of these because there's a lot going on. If you messed up any of them, then you're going to curse this thing as you have to go back and check them all to make sure you've gotten them all right. Like, it could be as silly as mixing up an x-intercept and a y-intercept kind of thing. I get that. So, yeah, I'm going to stop this here because I think we've gone kind of, that's a lot. This is a long section, so we will be revisiting this tomorrow for Thursday. We don't have class on Fridays because we usually, as a department, have meetings. Okay, sorry, let me go down to the bottom here. Okay. So we usually have meetings on Fridays, so we don't do classes on Friday, just like face-to-face. But so tomorrow we'll do more of this. Friday we're off. Monday, I'll put out the announcement of when our classes are again, and we'll do more rational functions. We will not escape this section probably until Monday, maybe Tuesday. Okay, but there's a lot going on with this. So it's a big section. Take your time doing it. You can, poke at it for a little bit, but don't demand too much of yourself if you're like, this is kind of tough. Yeah, it is. Okay. The polynomial one wasn't so bad, but this one's going to take a while. Okay. So I'm going to go ahead and stop recording here.